So now we're going to do a few more practice problems to help prepare you for the delta practice that you're going to be doing. So problem number 1, let's evaluate the ln of e to the 10th power. Right? So power property says that this power can really become a coefficient. So we really have 10 times ln of e. And ln of e is one of those special values from the first video. Ln of e is equal to 1. So our final answer is really 10. Okay. The common mistake that students would do when they see a question like this is they recognize that ln of e is 1, and they treat this as ln of e. And sometimes I'll see something like, oh, this is like 1 to the 10th power, and then they would get the answer of 1, which of course is not accurate. See, when you have ln of e to the 10th, you really have ln, and then in parentheses e to the 10th. So it's really not just ln of e. Question 2. How about if we had ln square root of e? So now having you recall some rules about radicals and transferring them to fractional exponents. So just as a side note, when we have something like the square root of e, we should recognize that, of course, that's e to the first power. And since this is a square root, we actually assume that the root is 2. And the conversion, I always think inside over outside. So it's e to the 1 over 2 power. Inside over outside is how I think of it. So we're going to rewrite this as ln of e to the 1/2 power, right? We're going to apply the power property. We're going to swing that 1/2 down as a coefficient. And then we can recognize that ln of e is 1. So this becomes just times 1. So 1/2 times 1 is 1/2. So problem 3. Let's do another one that has a radical in it. Let's do the 5th root of e, let's just say to the 4th power, right? So we want to apply the rule that we just went over in the last problem. We want to convert this to a fractional exponent, so we want to think inside over outside. So this is really equivalent to e to the 4 over 5 power. Okay. Apply the power property. And then we can make ln of e 1. So we get a final answer of 4/5. And how about we review a little negative exponent? So how about we do ln and then 1 over e to the 4th power. So 1 over e to the 4th power is really equivalent to e to the negative 4th power, right? So we can swing this up to the numerator as long as we negate the exponent. Then we can apply the power property. And then we can make ln of e 1. So we get a final answer of negative 4.